Well, we always share tons of things over the internet. We message our friends, watch videos on YouTube. Like this one. While doing all these things. Have you ever wondered how we even access these things? Today we're here with your answer, the OSI model. This 7-layer architecture explains the path data that you send over the internet or any network in general takes before it reaches its destination. Let's start our adventure from the top, the application layer, and travel down to the foundation, the physical layer. Ready? Let's go. Our journey begins with the application layer, the layer where you interact with the network directly. It's like the apps on your phone, your email, your web browser, even your online games. Application layer provides protocols such as HTTP, FTP, SMTP, DNS, POP3, DNCP, Telnet, and SSH, which enables data transmission, and this layer makes sure your requests are ready to go. But how does this data get ready for travel? That's where the presentation layer comes in. Imagine the presentation layer as a wizard. It transforms data into different formats, like turning text into code or encrypting a message for security. It ensures everything is in the right language before it's sent out. Protocols like SSL, TLS, JPEG, and SCI are added in this layer for encryption and decryption, compression and decompression, and data translation to ensure the data is in a readable format. Now, we need to manage our connections. Enter the session layer. Think of the session layer as the singer at a concert, keeping everyone engaged and enjoying the moment. It keeps track of sessions, so your video calls, online meetings, and gaming sessions run smoothly. It has checkpoints and verifies the data passing through specific points. If there's an issue, it can resend the data from the previous checkpoint. The session layer establishes, maintains, and terminates connections. It uses protocols that help manage communication between devices and ensure secure and reliable data transfer. Some examples include NetBIOS and RPC. With our session established, it's time for the transport layer to ensure everything travels safely. The transport layer is like a reliable delivery service. The data is segmented, and transport protocols, TCP/UDP, are added, creating segments. TCP and UDP ensure your data packets are delivered correctly and efficiently, like ensuring your package arrives on time and intact. Next, our data needs the best route to travel, and that's where the network layer comes in. The network layer is like your GPS, finding the best route for your data packets. It uses IP addresses to navigate through different networks, just like how you use a map to plan a road trip. The segments from the transport layer are encapsulated into packets. The IP address is added to these packets at this stage, determining the best route for the data to travel across the network. Some protocols used in the network layer are ICMP, IPsec, and RIP. After finding the best route, we need to sort and prepare our data for delivery. That's the job of the data link layer. The data link layer is like the post office, sorting your mail. Here, MAC addresses act like house addresses, ensuring each piece of data gets to the right place. Frames are the packages carrying your data. Some protocols applied in this layer are Ethernet, PPP, ARP, and Token Ring. Finally, we reach the physical layer, the foundation of our journey. The physical layer is like the roads and trucks that physically transport your mail. It includes cables, switches, and routers, moving your data from one place to another. Some protocols in this layer are DSL, ISDN, USB, and Ethernet. And that, dear viewers, is how data travels through the OSI model, layer by layer, from your application to the physical connections. The data unit travels through the application layer, presentation layer, and session layer. In the transport layer, it is broken down into segments. Then, it travels through the network layer, where packets are created by adding the IP address to the segment. Finally, the MAC address is added to packets, and they are sent through the data link layer as frames, where the data gets transmitted. Thanks for joining us on this journey. Don't forget to like, share, and comment on our video. We can't wait to see your thoughts.